The square root method. An important theorem is if x squared equals m, then x equals plus or minus the square root of m, provided that m is greater or equal to 0. And here is a proof that shows that. Alright, so here's an example. Solve for x. X squared equals 9. Therefore, x equals plus or minus the square root of 9, which would be negative 3 and positive 3. Here we have the graph of x squared, and we can see that there are two solutions for when y equals 9, and that is at positive 3 and negative 3. The two real solutions are confirmed by the graph, here and here. There are two inputs x that produce the output 9. Here's another example. X squared equals 5, therefore x equals plus or minus the square root of 5. So here we have the graph of x squared, and when x equals the square root of 5, which is slightly more than 2, we have a solution there and a solution there, where y equals 5. The two real solutions are confirmed by the graph. There are two inputs x that produce the output 5. The new theorem can be used with substitution. Here's an example. So here we have x minus 2 squared equals 5. The axis of symmetry of the graph is x equals 2. So it's no longer at the y-axis, now it's been moved over to the right 2. And the real solutions are symmetric with x equals 2. So when we solve this, we take the square root of both sides and we see that x minus 2 equals plus or minus the square root of 5. We'll add 2 to both sides and we get x equals 2 plus or minus the square root of 5, giving us two solutions here and here, 2 plus the square root of 5 and 2 minus the square root of 5. True or false? X squared equals 49 implies that x equals negative 7 or 7. This is true. If we take the square root of both sides, we get x equals plus or minus the square root of 49. The square root of 49 is 7. Therefore, it's plus or minus 7. So this is true. The square root of 64 equals plus or minus 8. This is not true. The square root of 64 is 8, positive 8. But if we had plus or minus the square root of 64, that would be equal to plus or minus 8, because the square root of 64 is 8. So that's how we would get plus or minus, not from this. All right, the next one, x squared equals 21 implies that x equals the square root of 21. This is also false, because x should be equal to plus or minus the square root of 21. It's just missing that plus or minus there. All right, x plus 5 squared equals 13 implies that negative 5 plus or minus the square root of 13. Yes, this is true. If we take the square root of both sides here, we get x plus 5 equals plus or minus the square root of 13, and then we can subtract 5 from both sides. We get x equals negative 5 plus or minus the square root of 13, which is right there. That is true. Square root of 81 equals 9. This is true. The square root of 81 is positive 9. If we wrote plus or minus the square root of 81, then we would get plus or minus 9. But because this isn't there, we're just looking at what the square root is of 81. That is only a positive number, and that is 9. And we got them all correct. Solve 2x minus 1 squared equals 20 using the square root method. All right, so we have 2x minus 1 squared equals 20. We will take the square root of both sides, and that gives us 2x minus 1 equals positive or negative square root of 20. We'll add 1 to both sides, and we're going to change square root of 20 is the same thing as the square root of 4 times 5, so we can take a 2 out. 2 times the square root of 5. So this is the same thing as this. Then we'll divide both sides by 2, and we get x equals 1 plus or minus 2 times the square root of 5 over 2. All right, so right here you can see that 2x minus 1 equals positive square root of 20 or the negative square root of 20. So you can solve those both separately, but at the end we get x equals 1 plus or minus 2 times the square root of 5 over 2.